So here we are at example 7 from the 0.2 number 2 set of notes. We have g of x is equal to this function. We're asked to graph this. Now just kind of looking at things, we can go ahead and actually factor this guy. And when we do that, we end up with 2x minus 1 times x plus 2. That's what this guy will come out to factor to. On the bottom, we can't factor anything, so it's still just x plus 1. Now the reason why we would do that is what we'll see in a little bit, known as holes, but again, we'll save that for a future example. But we kind of want to get into that habit of going ahead and possibly factoring right away. Now, when we're trying to figure out like our vertical and horizontal asymptotes and things like that, let's go ahead and let's find our... So let's go ahead and actually find our vertical asymptote right now. So our vertical asymptote is simply when we set our bottom not equal to 0. So we have x plus 1 is not equal to 0. And then we just solve for this, so it just comes out to be x is not equal to negative 1 when you subtract that 1 from both sides. And so we should see a VA occurring at negative 1. Now let's go ahead and find our HA, our horizontal asymptote. Well, we see that the degree is higher on the top than it is the bottom, and as a result, we actually won't have one. So this is none. Let's move on now to our slant asymptote. Well, we do have the degree on top is 1 larger than the bottom, so we can go ahead then and use that synthetic division to determine what is our slant asymptote. We know that we just go ahead and take the opposite of this guy. By the way, we can use synthetic division too because we are dealing with a division of a linear. So we can use synthetic instead of the long division. And when we do that, we're just going to go ahead and take the opposite of this value. So it's positive 1 there, we're going to choose negative 1. That's what's going to go inside of our box. And then we just drag down our coefficients from the others, from the ones on top. So we have 2, 3, and negative 2. Leave ourselves a space, draw a bar, and then we perform our synthetic division. So this first guy gets dropped down. Negative 1 times 2 just comes out to be negative 2. And we're going to go ahead and place him right under the next value for 3. And then we just add going down. So 3 minus 2 just comes out to be 1. And then we just repeat the same thing. So anything underneath this bar, we're going to go ahead and multiply. So negative 1 times 1 gives us negative 1. We just replace it under the next value. And then we add, again, as always, going down. So negative 2 minus 1 comes out to be negative 3. So now that we've completed our synthetic division, we are left with this 2, 1, and negative 3. Now when we divided this x squared by this power of x to the 1, we've actually brought down things down a notch. So in other words, instead of x squared, because we've divided it by x, we are left then with x, 2x, plus, since there's not a negative in front of this one, plus 1. And then finally, we have a remainder of negative 3. All right. So as a result, our slant asymptote will be the line y is equal to 2x plus 1. We don't really care too much about this remainder negative 3, simply because things will start to become insignificant when you start talking about like the limits of things, especially as they go toward infinity. So that's not really going to play too much of a role. Now let's go on to finding our X-Intercepts. We found those in the past. Let's go ahead and find those again. So for our X-Intercepts, all we have to do is go ahead and set our g of x equal to 0. So we're just going to say 0 is equal to... Now again, when we're trying to find X-intercepts, all we really need to do is set this top equal to 0. And that's kind of that like little trick that we saw in the past. And then just solve for x from here. Well, the bonus is we've already gone ahead and factored. So we have 0 is equal to 2x minus 1. And then x plus 2. And now using that zero product property, we can break these up. So we have 2x minus 1 is equal to 0. And x plus 2 is equal to 0. Solving for each one, we have this one will just come out to be 2x is equal to 1. So then when you divide 2 on both sides, it comes out to be 1/2. Over here, x will just come out to be negative 2. So again, since these are x-intercepts, those are specifically points, not an actual line, because right now these guys are lines. So we'd end up with the actual point, 1/2, comma, and then this guy would also come out to be negative 2, comma, because again, these are x values. Now, when we're referencing x-intercepts, that's where it's crossing our x-axis. So in other words, the y values are not going up, they're not going down any, they will always remain 0. And so those would be our x-intercepts. In fact, while we're on x-intercepts, let's go ahead and find the y-intercepts. Well, when we have our y-intercept, it's kind of that same idea, where we're trying to figure out where is it crossing this axis. Well, if it's crossing this y-axis, in other words, the y-intercept, it's intercepting the y-axis, notice we're not going to the left for x, or we're not going to the right at all for x. In other words, our x value is literally 0. We're not moving left or right any, so it has to be 0. So as a result, we can then go ahead and just plug in 0 anywhere that there is an x. So when we do that, we have y is equal to 2 times 0 squared plus 3 times 0 minus 2 all over 0 plus 1. And the nice thing about the y-intercept is when you plug it in, this whole thing will just come out to be 0, this will be 0, this is 0. So you just actually end up with a lot of zeros and then these constants that kind of actually then determine what our y-intercept is. So we have 0 plus 0 minus 2, there's negative 2 on top, over 0 plus 1 is just 1. So we end up with y is equal to negative 2. But again, this is actually just a line. We're talking about a y-intercept. In other words, where is it crossing that y-axis? So it should be a specific point. Well, we determined that we weren't going to the left or right any for x. So that's why he's 0. But our specific y value that we're seeing it cross happens to be at negative 2. So that is actually our y-intercept, 0, negative 2. So let's go ahead and plot some of these things. We just found the y-intercept. Here it is, 0, negative 2. Let's go ahead and plot our x-intercepts. 1/2 is 0, which is right there. And negative 2, 0, which is right here. We also found some other things like the vertical asymptote, which we've already graphed. Horizontal asymptote, we don't have any. But we do have a slant asymptote. Here it is, 2x plus 1. So we have 2x plus 1. That has a y, that b value of 1, and then that slope of 2. So up 2 over 1. Up 2 over 1. And so more or less, you should see at least an image that looks something like that. Now let's go ahead and create a table of values to kind of determine what is the general shape. I mean, we kind of have enough to actually go ahead and graph this, but let's play it safe and just kind of have a little bit more. I know that this should be hugging our asymptotes. Likewise, this one, it just should just hug them. So for our x and y's, again, that was a little rough. There we go. Let's go ahead and choose some x values to the right of our vertical asymptote. Like we can go ahead and choose like, well, we already have 0, -2, so maybe we'll do 1 and 2. So these are to the right. For the left, let's go ahead and choose like maybe negative. Well, we already have -2. We can do like -3 and -4. So when we plug 1 in, we actually end up with 1 and 1/2. And again, you can plug and chug. It's up to you. When you plug 2 in, you should end up with a y value 4. When you plug in -3, you should end up with -3.5. And when you plug in -4, you should get -6. So for 1, we have for 1 we have 1 and 1/2. For 2 we have 4. And you can kind of see it wants to hug that thing pretty badly, that asymptote. At -3, we end up with -3.5. And there you can see it's also wanting to hug this one down here, this asymptote. -4, -6. Looks like our graph might be a little off. Again, just from the actual imaging. So, yeah, happened right about there. Let's go ahead and make that a little bit more clear. So down to over 1. -4, -6. That's a little bit better. And now when we go ahead and connect all the dots, we end up with an image that should be something like this on the right side. And then on the left, we see a hugging going through these points and then hugging that slant asymptote. So that would be our solution, our graph, for example 7 from the 0.2 number 2 set of notes.